Hello student, in the last lecture we have seen that examples in question number 3 in exercise 1.3 means which is depend on implicit function. Now we take question number 4, show that dy by dx equal to y by x in the following, where a and p are the constant. So the first function, first example, x to the power 7 into y to the power 5 is equal to x plus y to the power 12. In this example, when we solve this example, we take log on both sides because here it is a product of two functions, taking log on both sides. We get log of x raised to 7 into y raised to 5 is equal to log of x plus y raised to power 12. Here we use rules of logarithm. Log of a into b, it gives log a plus log b. A means here log of x raised to 7. Log of x raised to 7 plus log of y raised to 5 is equal to log of x plus y raised to power 12. Now again we use next rule of logarithm, log m log n or log of m raised to n is n into log m. We use here this m means x and y, and this x plus y, n means here 7, 5 and 12. Again we use next rule, this rule, 7 into log x plus 5 into log y is equal to 12 into log of x plus y. So after that step we take its derivative. So differentiate with respect to x. We get 7 constant as it is, and derivative of log x with respect to x is 1 by x, plus 5 constant as it is into derivative of log y is 1 by y, into by chain rule. Again here we take derivative of y with respect to x is dy by dx is equal to 12 constant as it is, and derivative of log of x plus y is 1 by x plus y. Again by chain rule we take its derivative of x plus y. So it is a 7 by x plus 5 by y into dy by dx is equal to 12 by x plus y into derivative of x with respect to x is 1 plus derivative of y with respect to x is dy by dx. Now we multiply this term to this bracket. So 7 by x plus 5 by y into dy by dx is equal to 12 by x plus y into 1 as it is, 12 by x plus y plus again 12 by x plus y into dy by dx. Now we take the terms of dy by dx in the left hand side and without dy by dx term in the right hand side. So 5 by y into dy by dx is equal to, or take this term dy by dx in the LHS, it becomes minus 12 by x plus y into dy by dx is equal to, now this 12 by x plus y as it is, and take this 7 by x term in the right hand side without dy dx term, minus 7 by x. Now we take common dy by dx from these two terms. So when we take common dy by dx here, it is 5 by y minus 12 by x plus y into dy by dx is equal to this term as it is 12 by x plus y minus 7 by x. Now we take cross multiplication LCM here. So cross multiplication, it is 5 into x plus y minus 12 into y, it is 12y. Cross multiplication and LCM is y into x plus y into dy by dx is equal to, in the right hand side also we take cross multiplication and LCM here. Okay, so 12 into x, it is 12x minus 7 into x plus y divided by x into x plus y is LCM. Now we multiply 5 to this x plus y and 7 to this x plus y. So 5 into x, it is 5x plus 5 into y minus 12y divided by y into x plus y into dy by dx is equal to 12x minus 7 into x, it is minus 7x, and minus 7 into y, it is minus 7y divided by x into x plus y. Now here 5x minus plus 5y minus 12y, it becomes minus 7y divided by y into x plus y into dy by dx is equal to 12x minus 7x, it is 5x minus 7y divided by x into x plus y. Now we take this total bracket in the right hand side. In the left hand side, this total bracket is in the multiplication, in the multiple of dy by dx, in the multiplication. यहाँ पे ये टोटल ब्रैकेट जो है ये मल्टीप्लिकेशन में dy by dx का है. So we take this bracket in the right hand side. So dy by dx is equal to 5x minus 7y divided by x into x plus y into, take its reciprocal. Here it is y into x plus y divided by 5x minus 7y. When we take this bracket in the right hand side, it is in the division of these terms, and then we take its division into multiplication. We take its that's why it's reciprocal here. Now common term will get cancelled here. This bracket, also this x plus y, and it remains only y by x dy by dx, and hence we have to show that our function is dy by dx equal to y by x. Now take this next example. Sec of x to the power 5 plus y to the power 5 upon x to the power 5 minus y to the power 5 equal to a square. We take this sec in the right hand side, that's why it is a sec inverse. X raised to power 5 plus y raised to power 5 divided by x to the power 5 minus y to the power 5. is equal to sec inverse of a square. Now this is total constant, that's why we say it's b. It is a constant. B is a constant. This becomes x to the power 5 plus y to the power 5 divided by x to the power 5 minus y to the power 5 is equal to b. Now we take this term in the right hand side, x to the power 5 plus y to the power 5 is equal to b into x raised to power 5 minus y to the power 5. Multiply this b into x to the power 5 minus b into y to the power 5, and this as it is, this term is as it is, plus y to the power 5. Now we take this minus b into y raised to 5 in the left hand side and this x to the power 5 in the right hand side. So it becomes y to the power 5 plus b into y to the power 5 equal to b into x to the power 5 and this x to the power minus x to the power 5. Now we take common y to the power 5 here and x to the power 5 here. So it becomes 1 plus b into y to the power 5 is equal to, here when we take common x to the power 5, it is b minus 1 into x to the power 5. Now again we take this total bracket in the right hand side, then it becomes y to the power 5 is equal to b minus 1 or 1, yes it is b minus 1 divided by 1 plus b or b plus 1, it is 1 as same, b plus 1 into x to the power 5. Now again we consider this bracket, constant bracket, it is say c here equal to c into x to the power 5, where c equal to b minus 1 divided by b plus 1, or it is also equal to y by 5. When we take this x to the power 5 in the left hand side, it becomes y to the power 5 divided by x to the power 5. It is equal to also equal to y to the power 5 divided by x to the power 5. Now we differentiate with respect to x. We get, and derivative of y raised to 5 is equal to 5 into y to the power 5 minus 1, it is 4, by using derivative of x raised to n into x raised to n minus 1, into, again here by chain rule here we find the derivative with respect to x. That's why again derivative of y with respect to x is dy by dx is equal to constant c as it is into derivative of x raised to power 5, it is 5 into x to the power 5 minus 1, it is 4. Now we take this term in the right hand side, so it is dy by dx is only constant c into 5 into x to the power 4 and divided by 5 into y to the power 4. This 5 will get cancelled. It is c into x to the power 4 divided by y to the power 4. But c is here from equation, we call this equation number 2, second equation. Or it is also first or second, yes, it is second. First, We write the value of c here. C is here y by y to the power 5 upon x to the power 5. We write here c, the value of c is here y to the power 5 divided by x to the power 5 into this x to the power 4 divided by y to the power 4, and this becomes dy by dx. Now here y to the power 5 divided by y to the power 4. That's why we cancel out this with this, same as we cancel out x to the power 4 to this x to the power 5. It remains only 1y divided by 1x, and so this is dy by dx. Hence we have shown that dy by dx equal to y by x. Now take this next, cos inverse of 7x to the power 4 plus 5y to the power 4 divided by 7x to the power 4 minus 5 into y to the power 4 is equal to tan inverse of a. Now we take this cos inverse in the right hand side, then it becomes cos only, because in the previous example we take sec in the right hand side, it becomes sec inverse, but here it is cos inverse. That's why when we take in the right hand side, it is a cos only. 7x to the power 4 plus 5y to the power 4 divided by 7x to the power 4 minus 5y to the power 4 is equal to cos of tan inverse of E. Now again we say this total constant term B here, say now again we take this term in the right hand side, so it becomes 7x to the power 4 plus 5y to the power 4 is equal to this B into 7x to the power 4 minus 5y to the power 4. Now we multiply this b to this both terms, it is a 7 bx to the power 4 minus 5by to the power 4. This term as it is. Now we take this minus 5by raised to 4 in the left hand side and this 7x to the power 4 in the right hand side. 5 by square or 5y raised to 4 plus 5by raised to 4 is equal to 7bx to the power 4 and this minus 7x to the power 4. Again we take common 5y to the power 4 here, it becomes 1 plus b, it remains 1 plus b in the bracket and 5y to the power 4 is common. Same way we take common 7x to the power 4 in this side, so it remains b minus 1 into 7x to the power 4. Now we take this 1 plus b or b plus 1, it is one and same in the right hand side. So 5y to the power 4 is equal to b minus 1 divided by 1 plus b or b plus 1, it is one as same, into 7x to the power 4. Now again we put here, it is a constant, we say here it is c, this total bracket constant. So 5y to the power 4 is equal to, it is a constant c into 7x to the power 4, where c is equal to this b minus 1 divided by b plus 1, or also it is equal to, when we take this 7 into x to the power 4 in the left hand side, it becomes 5 into y to the power 4 divided by 5 into 7 into x to the power 4. Call equation number first. Now we differentiate it with respect to x. Differentiate with respect to x. We get, so constant 5 as it is, delta of y raised to 4 is 4 into y to the power 4 minus 1, it is 3. And by chain rule, delta of y with respect to x is dy by dx is equal to this constant c as it is into 7 as it is into x to the power 4 is 4 into x to the power 4 minus 1 is 3, and so it is 20 y cube into dy by dx is equal to 7 4 the 28 c into x cube. Now we take this 20 y cube in the right hand side, so dy by dx is equal to 28 x cube divided by 20 y cube into this c here, constant c. Now we cancel out here. 5 4s are 20, sorry 7 4 5s are 20, 4 5s are 20 and 4 7s are 28 here. It becomes 7 x cube into c divided by 5 y cube dy by dx. Now from equation 1 we put the value of c here. 7 x cube divided by 5 y cube into the value of constant c is here. It is c equal to 5y raised to 4 by 7 x raised to 4. 5y raised to 4 divided by 7x raised to 4. Now this 7 7 will get cancelled, 5 5 will get cancelled. Also here x cube will get cancelled from this x raised to 4 and y cube cancelled from y raised to 4. So it is only y and divided by x. It is y by x, it is dy by dx, and hence we have shown that, we seen that dy by dx equal to y. Hello. Next, this example. In this example here, we convert this log into exponential form by using here definition of logarithm. If a, m and x are the real numbers and a is not equal to 1, then such that a raised to x equal to m, a raised to x equal to m, then this x is called log m to the base a. This x is called as a logarithm m to the base a. So this is the definition of logarithm. So we use here, we have this form because here hidden e is here because it is a natural logarithm. That's why we know right to e here, only e here. So if this e, by using this definition of logarithm, we have this log m to the base e equal to x log this, suppose total bracket is x to the base e, so we write it exponential form. It is a to the power x equal to m. So m means here it is this bracket and x means here it is 20. So that's why we write here m means bracket x to the power 20 minus y to the power 20 divided by x to the power 20 plus y to the power 20 is equal to base to the power x, this term. So base e to the power this 20. So by using definition of logarithm. Now we take this term in the right hand side, x to the power 20 minus y to the power 20 is equal to e to the power 20 into x plus, or we say that here, first of all we say this e to the power 20 is b here, e to the power 20 is equal to b, we say it is constant. And after that we take this term in the right hand side, x to the power 20 minus y to the power 20 divided by x to the power 20 plus y to the power 20 is equal to b here. Now we take this term in the right hand side, x to the power 20 minus y to the power 20 equal to b into x to the power 20 plus y to the power 20. Now we multiply to this term b into x to the power 20 plus b into y to the power 20, and in this side x to the power 20 minus y to the power 20. Now we take this minus y to the power 20 in the right hand side and b into x to the power 20 in the left hand side. So it becomes x to the power 20 minus b into x to the power 20 is equal to b into y to the power 20 minus or plus y to the power 20. When we take in the right hand side, it becomes plus this term. Now we take common x to the power 20 from this term and y to the power 20 in this side. So when we take this common x to the power 20, it is 1 minus b into x to the power 20 is equal to, and in the right hand side we take a y to the power 20 is common. So it is b plus 1 or 1 plus b, b plus 1, 1 plus b. Yes, it is b plus 1 into y to the power 20. We take this, we interchange these both terms here, both terms of this side. B plus 1 into y to the power 20 is equal to 1 minus b into x to the power 20. We interchange both terms because we need here in this side y to the power 20 y. Now we take this b plus 1 in the right hand side. So y to the 20 1 minus b divided by this b plus 1 or 1 plus b, it is 1 as same, into x to the power 20. Now we take this constant bracket is c here is equal to c into x to the power 20 y to the power 20, where c equal to 1 minus b divided by 1 plus b, or it is also equal to, when we take this x to the power 20 in the left hand side, it becomes y to the power 20 divided by x to the power 20. Now we differentiate with respect to x. Differentiate with respect to x. So the derivative of y to the power 20 by using x raised to n, it is 20 into y to the power 20 minus 1, it is 19 into, by chain rule again we have to find the derivative with respect to x, that's why it is dy by dx is equal to constant c as it is into, again we use here derivative of x raised to n, it is n into x raised to n minus 1. So 20 into x to the power 19. Now we take this 20 into y to the power 19 in the right hand side, it is dy by dx is equal to constant c into 20 into x to the power 19 divided by 20 into y to the power 19. This 20 will get cancelled. Now we call this equation first. Now from equation 1 we put the value of c here. C is here y to the power 20 divided by x to the power 20. Therefore dy by dx equal to c. The value of constant c is y to the power 20 divided by x to the power 20 into this x to the power 19 divided by y to the power 19. Now we cancel out here y to the power 19 to here y to the power 20, also x to the power 90 to the x to the power 20. It is only y by x here, it is dy by dx. And in this way we seen that, or we show that dy by dx equal to y by x. Now in this example, the example is e to the power x to the power 7 minus y to the power 7 upon x to the power 7 plus y to the power 7 equal to a. This function is in the exponential form. In the previous example, it is a logarithmic form. We convert it into exponential form by using definition of log. Now this example is exponential form. We convert it into logarithmic form by using definition of logarithm. We have already studied. So that's why it is x to the power 7 minus y to the power 7 divided by x to the power 7 plus y to the power 7. It is equal to log a to the base this e. It is equal to, already seen that definition of log. We say this constant is b. Now we take this term in the right hand side, is equal to this b into x to the power 7 plus y to the power 7. Now we multiply b into x to the power 7 plus b into y to the power 7. It is x to the power 7 minus y to the power 7. Now we take this y to the power 7 in the right hand side and this b into x to the power 7 in the left hand side. X to the power 7 minus b into x to the power 7 is equal to b into y to the power 7 and this plus y to the power 7. Now we take common x to the power 7, 1 minus b into x to the power 7 is equal to, here we take common y to the power 7. It is b plus 1 into y to the power 7. Now we interchange its places here. So b plus 1 into y to the power 7 is equal to 1 minus b into x to the power 7. Now we take this b plus 1 in the right hand side. Then it becomes, therefore it is y to the power 7 is equal to 1 minus b divided by b plus 1 or 1 plus b, it is one and same, 1 plus b into x to the power 7. And we put this constant bracket is c here. Y to the power 7 is equal to c into x to the power 7, and where this c equal to this constant 1 minus b divided by 1 plus b, which is also equal to y by 7 divided by x by 7. Call this equation 1. Now we differentiate this equation with respect to x. Differentiate with respect to x, we get, so the rate of y raised to 7 is 7 into y to the power 7 minus 1, it is 6 into by chain rule dy by dx is equal to, again constant c as it is here, into the rate of x raised to power 7 is 7 into x to the power 7 minus 1, it is 6. Now we take this 7 into y to the power 6 in the right hand side. This dy by dx is equal to constant c into 7 into x to the power 6 divided by 7 into y to the power 6. 7 will get cancelled. Now we put here the value of c from equation 1. So dy by dx is equal to the constant, the value of constant c is here y by 7, y to the power 7 divided by x to the power 7 into x to the power 6 divided by y to the power 6, and we cancel out here x to the power 6 to this x to the power 7 and y to the power 6 to the y to the power 7. So it is only, it remains only y by x, it is dy by dx, and hence we have show that dy by dx equal to y by x. And today we'll stop here.